We'll proceed in vector algebra and calculus. Vector algebra and calculus. Vector is considered as pioneer in mathematics. There is nothing beyond the vector. Vector, theoretically also, right? Means vector is combination of magnitude and direction. If we talk about direction, then it has x component, y component, and z component, and so many components. Each component, if each component is numeric, then vector is called numeric vector, static vector. But each vector is algebraic, then it is called algebraic vector. Or rather, I would say the numeric vector is a special case of algebraic vector as far as vector is concerned. So it is now inevitable, it is natural that person has to learn how to do calculus on vector. First understand what is vector and then how to do calculus on the vector. So vector is the future. Vector is only vector is used in artificial intelligence and machine learning. Vector. So we are following. So in vector, we have seen few aspects, and one of the aspect is curve length. If I have a curve, if I have a curve, if I have a curve, then how I can find the length? That we have seen through three ways I can find the length of the curve. One is primitive calculus, that is first try to find out the curve vector. If you have a vector, primitive calculus says if you have a vector, if you have a vector, then calculate the magnitude of vector. Make sure the vector x component is 1. Vector x component is 1, I plus whatever j you have. Calculate the magnitude of the vector, whatever magnitude comes. Now, if you want to calculate the length, then any vector has two directions if it is two dimensional. It has two components. One is x-axis and one is y-axis. Along x-axis, if I want this vector length, vector means this is one point, this is another point. This is the length of the vector or length of the line, length of the curve I want to calculate. If I find this vector and that vector must have x component as 1, calculate the magnitude and then multiply by the x component of this vector from where to where. It is 0 to a, multiply it by a. 0 to any variable x, multiply it by x. Now, if that is the case, then magnitude multiplication with the x-axis is the net length of the vector that represent the curve. Okay, since magnitude into x-axis, it becomes like a integration and magnitude is dependent upon x. Rather, we write magnitude into dx, integration from 0 to x. This is the way we calculated the primitive calculus way of calculating the curve length. What is, if this is primitive calculus, then what is the new calculus, new approach? New approach says that if try to find the curve vector, if you have a vector, if someone has a vector, if someone has a vector, consider this is x-axis and this is the vector. This is x-axis, this is x-axis, this is x-axis, and this is the vector. Now, this is vector, this is x-axis. Now, this is origin. If this is origin, take any point x and try to get the fx. This is the point on the vector that is x. This is the point on the vector that is x comma y. This is the point on the vector that is x comma y. If it is x comma y, then this is x and this is y or fx. This point is x comma function over x comma function over x, and this is x. Now at this point, I know this point, this is p. Now from x, I take delta x distance. Now this point is x plus delta x. If that is the case, the new point here is x plus delta x, comma, function over x plus delta x. If I connect these 2 points, it makes a vector. This is new approach, delta x approach. That vector is nothing but x plus delta xi, x plus delta x minus xi plus fx plus delta x minus fxj. If I settle it down, then it becomes delta xi plus fx plus delta x minus fxj. That is the vector. If that is the vector, then if I calculate the magnitude of this vector, then this magnitude belongs to delta x in x-axis, along the delta x along the x-axis. That is the equivalent magnitude of this vector. What about full? I want to, this is origin, from origin to any distance x, full. This is the region on x-axis that belongs to full vector. This length I want, but I calculated only for delta x. For delta x, vector is delta xi plus fx plus delta x minus fx j. Okay, then I have to, like that, I have to divide it into many pieces, small pieces, and then find the separate length and add it anyway. We proceeded on this. This all are our proof only. There is no, it's not available anywhere else. So if that is the case, then delta xi plus fx plus delta x minus fxj is equivalent, if I divide by delta x, multiply it by delta x, same thing. Now it becomes I plus fx plus delta x minus fx divided by delta x. That is completely equivalent to dfx by dx. I plus dfx by dx j into delta x. Okay. Now if I calculate the magnitude of it, then it becomes 1 square plus dy by dx whole square root delta x. This is length for one subsection that belongs to delta x. If delta x belongs to ith subsection from origin, if I take ith subsection, then all subsection I have to add. Now it becomes, as per the integral calculus, it becomes 0 to x square root of 1 square plus dy by dx whole square dx. This is the new approach. Third approach what we use to calculate the curve length is, if I have a curve, if I have a curve, and on the curve, if I have any point P, and P is the position vector, then it denotes the displacement vector. dP by dx denotes the velocity vector. If dP by dx is the velocity vector, then its magnitude is velocity magnitude. If its magnitude is velocity magnitude, if I integrate it back with the dx, I'll get the displacement magnitude. That is what we want, curve length. And that also gives the curve length. Three-way in the curve length. Can I go in 3 dimensions now? This is 2 dimension. Now question is arising, can I go in 3 dimensions? I try to cover full 3 dimension. If it is undigestible, then we will take in 2 sessions. Okay, sometime it becomes really very difficult. Anyway, now consider this is a sphere that is 3 dimensional. This is a sphere that is 3 dimensional. I have to calculate surface area of this sphere. Earlier we calculated earlier we calculated the curve length. We calculated the curve length. Now I am trying to calculate the surface area of this sphere. They are similar, right? In 2-dimensional, I have to calculate curve length. In 3-dimensional, I have to calculate the surface area of a sphere. Can I use similar fundamental? Now, if I go with primitive calculus, then I have to calculate a vector whose x-axis side is 1, calculate its magnitude and multiply it by, simply multiply it by x. You get the vector length. If the magnitude what we are calculating, it is dependent upon x, then multiply it by dx as per the primitive calculus. If you multiply it by dx and integrate 0 to x, that is the net kind of curve length. Please watch previous video. If that is the case, then how I can calculate surface area of a sphere? Surface area of any 3 dimension. Now, if you watch closely, if I wanted to calculate the length of this curve, then I had 2 axes. Okay, one axis is, if I wanted to calculate length of this curve, then I had 2 axes. One axis is x-axis and one axis is y-axis. x x-axis and y-axis. So this is the curve, kind of kind of it is stranded in x-axis, y-axis. Now, if I talk about 3D, then what are the axes that are involved? Then I have x-axis, y-axis. This is xy plane, and then this is z-axis, x-axis, y-axis, and z-axis. Now, this sphere is in kind of xyz coordinate system. Now this, if I see that what are the area it is covering in xy plane, then I have to bring it down, or from top I can see, or from here, whatever the area that is under this ball, that is the region of the xy plane. That for that we are taking the coordinate. It has a coordinate, right? If I take any point P here, okay, if I take any point P here, it has a coordinate x comma y comma z. If that is the coordinate, then it belongs to, then z is height where x and y is taken from this plane. What is the reason over which I have taken x comma y? I cannot take x comma y full plane. Some reason. That is the reason that comes under this ball. That is a circular region. I have to take x and y from that region only. Okay, anyway, this is the idea is to calculate the surface of this ball. Now, the earlier independent component was x-axis. X-axis was independent component and dependent component was function over x, fx or y. Here independent components are x and y and function over x and y is z. Z equal to small f in bracket x comma y bracket close. Z equal to function over x and y. That is called z. Okay, so the height is function over x and y. What is the relationship between x and y? No relationship. X and y both are independent to each other. If that is the case, now I have to find the surface area of this sphere. Now, how I can find surface area of this sphere? When I wanted to calculate curve length, then let's go by the primitive calculus. To get the curve length, we first calculated the curve vector. If I take any point x comma y here and connect from origin, then this vector is called position vector. That is xi plus yj. But this is not the curve vector. If I differentiate this vector, the net vector that comes, that vector is the curve vector. That will go along the curve. We want curve vector. We don't want position vector. If I have the curve vector that is along this, that curve vector, I calculate the magnitude and multiply it by dx and integrate 0 to x. This is what we have seen. That gives the kind of curve length. Similarly, if I am looking for surface, then if I watch it very closely, if I watch a house, if I watch a home, okay, then I think, then typically I think that this house is made up of brick. The standing force of this house are bricks, wall. So if I break the wall, then house will fall. Anyone would think in this fashion. If someone is seeing a house that is erected and he want to destroy it, then he will go and he will start hitting on the wall, thinking that if he destroy the wall, then house would fall. Then he took out bricks, but house did not fall because house is standing on four pillars only, three pillars only, whatever it is, two pillars only, or on a single pillar only. So pillar that is in one or two, three, four in number, that is taking full load of the building. Similarly, if there is a ball for which surface area is this big, then it is also standing on some pillars. Those pillars are x-axis, y-axis, and z-axis. Only three. Only three. This big sphere is standing on it. Only three. Okay, if that is the case, if I take any point here, that is P, any point P, consider this ball is centered at the origin. If it is centered at the origin, then this is xy plane that will cut it at the equator, at the center. So half of the sphere is above the xy plane, half of the sphere is below xy plane. So this is above and this is below. This sphere is centered at the origin. If I take any point P here, if I take any point P here from center, if I draw a line from center, if I draw a line, that is called position vector. Now position vector is xi plus yj plus zk because that P point is x comma y comma z xi plus yj plus zk. Now that P, any point has only three components. If it has three components, then it has two circle only. Hup, hup, hup. But it looks like fair, smooth, not like that. So it has two circle only. Any point P, if I take this P, any point P, if I cut vertically, it will make xz plane circle. If I cut vertically like this, it makes YZ plane circle. This circle, this circle. Where is your point P? Point P is here. Okay. Now, if I do like this, okay, if I have cut like this, where is point P? Point P is here. Okay. And XZ plane point P is here. Okay, if that is the case, now what is the primitive way of calculating it? Primitive way, get the curve length, get the primitive way is the first get the curve vector at point P in XZ plane. Get the curve vector at point P in YZ plane. First do it. There we will see. If I get like that, if I get a vector curve vector in xz plane, where vector it is so smooth and 360 not required. It is standing on xz plane, it is standing on yz plane only. It looks like a house, but it is standing on pillar only. That is the inside of the mathematics. Mathematics, if you start solving, what you look from the eye, then you will be gone. Look from the inner eye. That is the mathematics. So here, if you kind of now this is xz plane, this is circle. What is the curve vector in xz plane? Curve vector, if I see through primitive calculus also, what is the curve vector? If I take this point, what is the point? That is xi plus yj plus zk. That is P. Differentiation of this would give the curve vector. The curve vector is I plus dz by dxk. I plus dz by dxk. Okay, this is the curve vector in xz plane. What is the curve vector in yz plane? That is same P, dp by dx, dp by dy. dp by dy will give curve vector in yz plane. That is xi plus yj plus zk. dp by dy will be j plus dz by dyk. One is I plus dz by dxk, one is j plus dz by dyk. Now these are the two vector. One x component is 1, one y component is 1. Very nice, right? Now, if I want the surface area, if I have two vector at same point, consider this is the point. Here I have two vectors. Here I have two vectors. If I want surface area, I have to cross these two vectors. If I cross these two vectors, then I get the surface area internally. Okay, so we will multiply it dp by dx and dp by dy. So at this point, what are the two vectors? One vector is like this. This is a tangential xz plane. Another vector is like this in xz plane, yz plane. So if I cross this, then surface area will be along this line. That is tangential surface area at that point. Tangential surface area is different at different points. So at this point, if I make cross of these two dp by dx and dp by dy, then it will give me tangential surface area at each point. If that is the case, then we go ahead. So dz by dx is I plus dz by dy, dz by dx k. dz by dy is j plus dz by dy k. If I do cross product of these two, then I get the surface area vector. That is I plus dz by dxk cross j plus dz by dyk. If I do cross product, then it will become minus dz by dxi minus dz by dyj plus k. Okay. Now to get the net, this is the surface area vector for the two vector whose x component and y component is 1, 1. Okay, for one vector, that is I plus dz by dx k. One is j plus dz by dy k. If that is the case, then surface area vector is minus dz by dxi minus dz by dyj plus k. Alright, right? I plus dz by dxk cross j plus dz by dyk. If I do cross, then I cross j is k. I cross k. I cross k. I cross k would be minus j. That is dz by dy k. dz by dy j. Okay. Next is dz by dx k with cross with j. That will resolve in minus I. dz by dx minus I. Now dz by dxk dz by dyk, that is gone. So it becomes 1 plus dz by dy, 1 minus dz by dyj minus dz by dxi. That is minus dz by dxi minus dz by dyj plus k. Now this is the surface area vector. Now through the fundamental of primitive calculus, if I have a vector, please watch previous video for two dimensions. If I have a vector, if I have a vector whose x component is 1, if I calculate the magnitude and multiply it by x, it gives me the net vector length. If I just calculate the magnitude of a vector, this gives me the vector length. Multiply it by x, then for x, that is 0 to x, that much is the net length. This is what we are interested in. So here it is dz minus dz by dxi minus dz by dy j plus k. This surface area belongs to two vector cross product. One x component is 1 and one is y component is 1. Now magnitude of these two multiplied by dx multiplied by dy. Please watch previous video. Urgently required. Okay, so multiplied by dx multiplied by dy, or if I say multiply by x and multiply by y. But since this is a dependent component, one place dependent component in the sense when we are calculating the first vector, that is I plus dz by dxk, the k component, the if I take the position vector I plus j xi plus yj plus zk, z is a dependent component. Z is not independent. X and Y are independent component, or XY plane is independent component. Z is dependent component. If Z is dependent component, and at the end we have calculated the surface area vector minus dz by dxi minus dz by dyj plus k, this full surface area has Z, means this full arena is a dependent component, dependent upon x and y. If I calculate magnitude of this, then this is again a dependent component on x. If I multiply it by x and y, this comes as calculation of the area, calculation of the integration, where x and y are independent and this one is dependent. It will transform into integration over xy plane, integration over a region in xy plane, magnitude of this vector dx dy. This will give the net 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 surface area. So what is this? If it is centered at the origin, what is the region in xy plane? So I can say circular region in xy plane, magnitude of the surface area vector dx dy. This is primitive calculus because we have not taken any delta x and delta x tends to 0 and this kind of thing. Only algebra. Algebra only means dependent component, independent component. That is calculus algebra. and dependent component, independent component, and there we came of multiplication of dependent and independent. If that comes into the picture, then quickly we change the independent from x to dx and place a limit, because it has to pass through calculus. It has to pass through polynomial area calculation. That is straightforward if it is rectangular, otherwise it is not a straightforward. In that case, it becomes calculus algebra multiplication. That is different than normal multiplication. So calculation of area is different. Is coming in that form only. Magnitude of the net vector into xy plane. That is that is x into y. We will settle it down as limit on the xy plane, circular region on the xy plane, magnitude of the surface area vector dx dy. What is the magnitude of the surface area vector? Minus dz by dxi minus dz by dyj plus k. What is its magnitude? Dz by dx whole square plus dz by dy whole square plus 1 square root dx dy and integration over a circular region, because I had taken x and y from a circle only. Beginning only I showed that has taken x and y points have been taken from a circle, not the full xy plane. That circular region over which we have to take x and y in the integration. Okay, if that is the case, then what is dz by dx? What is x? X square plus y square plus z square equal to a square is the equation of a, this is the equation of the sphere. Then z equal to square root of a square minus x square minus y square. That is z fxy. Dz by dx, that is minus x by square root of a square minus x square minus y square whole square, x square by a square minus x square minus y square plus dz by dy whole square, y square divided by a square minus x square minus y square plus 1 square root. If someone settle it down, it becomes a by square root of a square minus x square minus y square dx dy integration over a circular limit. The isn't it like analogous, similar to calculating the curve length of the circle, where it was a by, I remember, a by a square root of a square minus x square dx, and limit was in a circular region x minus a to a or 0 to a. Similar, right? A by square root of a square minus x square minus y square dx dy integration over the circular region. What is the circular region? Circular region is x is minus a to a and y is minus square root of a square minus x square to square root of a square minus x square, because it's a circular region, right? If it is a circular region, then again dependency exists as far as limit is concerned. That is not a very favorable behavior, but at the end we have to go by it. So if I calculate it, then better we convert it into polar coordinate system. Or if I try to calculate through Cartesian coordinate only, then consider x equal to square root of a square minus y square cos theta. Just consider, like, I'm not going to any coordinate system. X equal to square root of a square, or y equal to square root of a square minus x square cos theta. If that is the case, then it would settle down. To settle down as a, I can keep outside 1 by square root of a square minus x square minus, and y is the square root of a square minus y square. A square minus y square. I don't know. Let's see. A square, a square root of a square minus x square minus y square. Minus y square will convert into a square minus a square plus x square cos square theta. Okay, I believe it is all right. So if that is the case, then how it will settle down? 1 by square root of a square minus x square minus, and y becomes a square minus x square cos square theta. Okay, if that is the case, I don't know. Okay, if that is the case, then a square minus x square root would come out. Now it becomes a I have taken outside. 1 by square root of a square minus x square root of 1 minus cos square theta. That is 1 by square root of a square minus x square sine theta. And dy becomes square root of a square minus x square. We have taken cos cos theta becomes minus sine theta d theta. Sine theta gone. A square minus x square minus came there. Minus d theta. This is what I think so. Minus d theta dx. Now integration of minus d theta. Okay, integration of minus I can keep outside, that is minus a. Now minus a, and x is minus a to a, y is minus square root of a square minus x square to square root of a square minus x square. Here only d theta remains. D theta integration is theta. Now where is from theta to theta? Now here y equal to square root of a square minus x square cos theta. Means when y is minus square root of a square minus y square, cos theta is minus 1. If cos theta is minus 1, that is minus pi, I believe so. Now if it is y is square root of a square minus y square, then cos theta is 1, that is 0. So pi to 0, this becomes 0, this becomes pi. Okay, this integration becomes pi. Pi outside, pi to 0, minus pi, minus is anyway kept outside. Now I can keep pi a outside, pi a outside. I believe, all right, I don't know. Pi a outside, first time also I'm trying this way. Pi a outside, otherwise generally people convert into polar coordinate system. So pi a outside. Now dx, integration of dx is x minus a to a, that becomes 2a, 2 2a square pi. 2 pi a square is the surface area of this sphere, but we have calculated top hemisphere only. This is centered at the origin, and x, y, whatever we have taken, that's it for top hemisphere only. Bottom I have not calculated, but I know it is double of it. 4 pi a square is the surface area of a sphere. Amazing, right? So this is the way, through primitive calculus I can calculate the surface area of this. I believe my head is really spinning. So this is the primitive way of calculating the surface area of a sphere. Okay, what is the new calculus way, that is delta x way? And then dy by then the velocity vector. There is third method, three methods we have discussed, right? So velocity method, so that we will calculate. What is the new way of calculating the surface area? New way of calculating the surface area is again, so here again, now here again same thing we will have. We have xz plane and yz plane. In xz plane, what is the curve vector? So xz plane, rather than calculating the curve vector, what rather than calculating the curve vector, what is the new way? This is the xz plane. This is yz plane. This is xz plane. This is yz plane. Here is the p. This is the position vector. What is the position vector of p? If this is p and its point is xi plus yj plus zk, if it is x-axis, then okay. If this is the center, this is the center, this is x, this point is x comma y comma z. This is z, this is x, and this is cut at any y. Okay, so then this position vector is xi plus yj plus zk. If I go delta x, then there is a new point comes into the picture, that is x plus delta x comma y comma mu z. What is mu z? That is fx plus delta x comma y. Z is fxy, function over x and y. One point is xi plus yj plus zk. Another point is x plus delta xi plus yj plus, or sorry, one point is x comma y comma z. Another point is x plus delta x comma y plus f x plus delta x comma y. So first point is x comma y comma fxy. Another point I moved from x delta x. Another point is x plus delta x comma y comma fx plus delta x comma y. If I subtract these 2 points, it becomes a vector. If I subtract 2 points, then it becomes a vector as per the vector fundamental. What is that vector? X plus delta x minus xi plus y minus yj plus fx plus delta x comma y minus fxyk. That is the vector. What is this vector? Now, if I settle it down, it becomes delta xi plus fx plus delta x comma y minus fxy k. This is the vector. If this is the vector, then silently I can if this is the vector, then silently I can, the way we did in 2 dimensions, same thing we will do here also. Then if I divide it by delta x, then I have to multiply it by delta x. Then it becomes I plus fx plus delta x minus fx plus delta x comma y minus fxy divided by delta xk. It is same as I plus dz by dxk into delta x. Now, if that is the case, we keep it. This is vector number A. I call it A vector. Now, in YZ plane, same thing will proceed. I believe it will take a lot of time. Now, that is the modern calculus way, that is, will calculate the surface area. This is not available in any of the book. This methodology is not available in any of the book. Please do support us. +91 is the India country code. 9483160610 is the telephone number. Available in the description also. 9483160610 is the telephone number. +91 is the India country code. Okay, so we will proceed in the modern calculus way in calculating the surface area and velocity vector, acceleration vector. Through that also, we will calculate the surface area. There are many things. One is called elliptical calculus, elliptical integral. So those things also we will discuss. Nothing, no stone we will leave unturned. So that we will see.